Welcome to Code Report. I'm your host, Connor Hoekstra. Last week we had 6 contests, 3 from Code Forces, round 534, round 535, and Educational 59. Also on Saturday, we had from CodeChef the lunchtime contest, from Top Coder SRM 748, and from Leetcode the weekly Leetcode contest number 121. Taking a look at the top 10 leaderboards for the Top Coder, CodeChef, and Leetcode contests, there were only 2 individuals to place on multiple top 10 leaderboards here, and those 2 individuals were Tourist, aka Gennady, and Yui. So Tourist placed first in both the Top Coder and Lunchtime contest, no surprise there, and Yui placed first in the Leetcode contest as well as 5th in the CodeChef contest. Taking a look at the top 10 leaderboards for the Code Forces contest, we didn't have any individuals placing on multiple top 10 lists, but we did have some familiar names. In the Division 1 round 533 contest, in first place we had MNBVMAR, in second we had WHZZT, in third we had AID, in fourth we had Dotaria, and in fifth we had TLE. And in the Educational 59 contest, in second we had Raidwoosh, and in fourth we had Eddie 1021. Taking a look at the overall top 10 for the Code Forces website, the number 1 spot, there was no change. That still belongs to Tourist, but Raidwoosh dropped from 2nd down to 8th, and that means that everyone from 3rd place to 8th place previously has now moved up 1 spot. So in 2nd is Vuv, in 3rd is Umnik, in 4th is Piotr, in 5th is Eknerwala, in 6th is LHIC, and in 7th is WXHTXDY, formerly known as 000. And in 9th we have VN_NV, and Dotaria managed to jump back into the top 10 here. In today's video, we're going to be covering the solution to problem 1 from the Leetcode contest number 121, entitled String Without AAA or BBB. The problem states, given 2 integers a and b, return any string s such that s has length a plus b and contains exactly a letter a's and b letter b's. And the other 2 conditions are that the substring 3 a's in a row and the substring 3 b's in a row do not occur in s. So we can only either have 1 b or 2 consecutive b's, and the same goes for a. And the constraints for this problem are that the value of our integers a and b, denoting the number of a's and b's we want to be in our string, is going to be between 0 and 100 inclusive, and it is guaranteed that an s exists for which we will be given the a and b for. So let's take a look at the 2 examples that Leetcode provided us with. So here are our 2 examples. The first one, we have a is equal to 1 and b is equal to 2, meaning that we want to see 1 a and 2 b's in our final string. And the output is as follows. So they say that they're going to give a at the front and then followed by 2 b's, but they also say that there's a couple other valid solutions. So we can have BAB or BBA. And this problem is, or this example is pretty trivial because there's actually no way to construct an invalid string where you're going to end up with 3 A's or 3 B's in a row, given that you're using the actual correct number of A's and B's that the problem wants. But for the second example, it is a little bit less trivial. So we have A equal to 4 and B equal to 1, and there's only one valid solution, and that's where the B is in the middle spot with 2 A's on either side. If we put B in any other position and still have the 4 remaining characters as A's, you're going to end up with at least 3 A's next to each other, and possibly even 4. And the problem states we can't have the substring 3 A's in a row. So this is actually a pretty simple problem, but the reason that I'm covering it is because I'm going to show 7 different C++ solutions, and my goal was to try and take what was a very ugly solution at first, the one that I submitted during the contest, and to try and make it look a lot nicer using algorithms, because this is a question where you're basically just going through and generating a sequence or a string. So we should be able to either make use of the algorithm generate or some other algorithm. So I'll first start off by showing the solution that I submitted and then I'll move on to other solutions after that. But before we get to that, the general idea here is that what you want to do is start with your two integers a and b, and whichever one is greater is going to be the character that you add. So in this case, when a is equal to 4, because we know that there's going to be more a's in our string, we can safely add an a to the beginning. And then we can basically at this point decrement the number of a's that we need to add. So it'll be 3 for a and 1 for b, and we can compare the two numbers. And if for any given point the difference between the two is greater than 1, so that means 2 or more, we know that we basically need to put some a's or b's, whichever one is the greater number, 2 in a row, because that's the most that we can put in a row without sort of violating the conditions of this problem. So because when we have 3 and 1, the difference is going to be 2, we would add another a, and at this point, we keep track, well, we've got 2 a's, so we know we need to add a b. So if we just keep track of some sort of Boolean flag, we can flip over to add a b, and then at this point we can still make a comparison and check, what's the difference between a's and b's, and we're going to have 2 a's to add and 0 b's, so we'll just end up adding. So the gist of this problem is keeping track of sort of the difference between a's and b's, and then toggling every once in a while if we have to add another character based on the fact that we've added 2 in a row. So let's take a look at the code for that solution. So here it is. We have our function str without 3a, 3b, and it takes 2 parameters, our integers a and b representing the number of characters of those kinds that we want to show up, and our function just returns a string here, which is going to be our final string. So you can see at the top, we're just declaring an empty string. We're declaring a Boolean for whether or not it's a's turn or b's turn. If a is greater than b, then we're going to set this to true because we want a to go first, we want the character a to show up first in the string. Otherwise, it's going to be set to false, so b can go. And then we have this local n, which is just equal to a plus b, which is going to be the final length of our string. And we're going to set up a variable I, which is going to be sort of incrementer to keep track of the length of our string. And then we enter a while loop. So while I is less than n, if it's a's turn, we take a look, what's the difference between a and b? If it's greater than 1, then we know we want to add 2 a's. And then we want to do a plus equals 2 to our sort of index or iterator here, or keeping track of how many characters we have so far. And then we want to do minus equals 2 on a, meaning the number of a's that we still have to add. And if the difference between a and b is 1 or less, then we can just add 1 a and make the corresponding increments and decrements on I and a. And if it's a's turn, or if it's b's turn, we basically do the exact same thing. So we could clean this code up, put this little piece in some sort of lambda or function so that we're not duplicating things, but I just showing this because this is what I submitted, and we'll look at nicer code towards the end. And then for each step through this while loop, we need to toggle a's turn to be b's turn, and when it's b's turn to be a's turn. And once we finish this while loop, we will have our string. So this is not an awful solution. It's pretty nice, but given what we're doing here, we're just basically creating a string. I figured we could try and find a nicer way to do this. And so I tried to solve this using the generate algorithm. So you can see here that I basically just constructed a string using the fill constructor to have a length a plus b, and then I just filled it with a question mark to begin with, and then called generate with a lambda that basically has a local variable c that's initialized in the capture list. And when it's less than 0, we're adding the a's, and when it's greater than 0, we're adding b's. And then it's basically keeping track of how many a's and b's were added based on the value of c. So if it's equal to 1, that means we've only added 1. If it's equal to 2, we've added 2. But ultimately, there's a couple different cases that this doesn't cover, and I could have continued to do more work on this to get it to work. So note, this does not work. There is a version of this solution that could work, but I realized that there is an easier way to solve this with a different algorithm, and that is with replace if. So we're going to take a look at the first version of that by just making use of the basically plain vanilla replace if before we start implementing our own. But basically the idea here is you use, once again, the fill constructor, and you construct your string initially to have all a's or all b's based on whether or not there's more A's or there's more B's. So if there's more A's, you're going to construct your string to be all A's at first and vice versa. And then what the idea is that you're going to go through, and for every third element, you're going to replace that with a B. And then that could be all we need, which is why we've got, that's what the first replace if takes care of. But we have a second replace if that goes through and replaces every third character starting from the second character in the string, not the third. And we are basically, while we're doing these replace ifs, we're decrementing the number of either A's or B's, whichever one there was less of, that we're sort of replacing some of the A's or B's with. We're decrementing them every time we hit that third index. So as soon as this goes below 0, we're no longer going to be replacing A's with B's. We'll still be sort of making our way through this algorithm, but we won't be doing any replacements because it's a replace if. We only replace when this predicate, this lambda, returns true. So once p.second, and I guess I sort of glazed over this, but this is a pair here, and so based on whether there's more A's or more B's, we construct a pair combining the character that we're going to be doing replacements for and the number of those characters. So p.second refers to the number of replacements that we actually need to do. So we know that once we get through both the first call to replace if, where we're initializing sort of the index that we're going to be replacing to have like no offset, but for the second replace if, we are going to have an offset. So the first replace if replaces every third character because we're doing a modulus here by 3, and the second replace if is doing the same thing, but it's doing an offset. So it's going to be the element to the left of every third character. So it's still technically every third character, it's just on a different offset. And by doing this, we basically have constructed a valid string. Because we know we're going to ensure that at no point do we have 3 A's or B's in a row, and by our replacements, the maximum of either A's or B's also is going to be 2 at most in a row. So this works, and this is a valid solution, but it doesn't look very pretty. And a couple of you are probably thinking, why are we making 2 calls to replace if, when really you only need to loop over your initial string once? And that is true. So the next solution basically combines the 2 different replace ifs by making a more complicated lambda that basically, here you can see we're doing the same things. We are returning false anytime our p.second is less than or equal to 0. We're still doing our decrements, but we have this extra condition. So here we're returning true when we have I modulus 3 equal to 0, but we're also returning true when we have I plus 1 modulus 3 equal to 0. And note we have this d greater than 0 here. This is basically equal to the extra number of characters that on our second pass, so in the previous solution when we had replace if 2 calls to it, the number of replacements that would have ended up happening in this replace if is what d is equal to. And we can calculate that by basically taking how many, if we assume that we constructed our string to have A's to begin with, we can look at how many B's are we going to have to add, and basically subtract from that the number of B's that we are going to add on our first pass through the first replace if. And we can get that by just the length of our string divided by 3. And if this could be a negative number, in which case we're never going to enter this else if statement because d needs to be greater than 0. But if this is a positive number, we're going to at times enter this, and then on top of decrementing p.second, which is the number of B's we'd have to add, we also have to decrement d. And so once this is equal to 0, we're no longer going to be returning true. And so otherwise we return false. And p.first is just the character that we're going to be replacing. So this works, only 1 call to replace if, but this lambda is absolutely atrocious, and so I don't recommend writing code this way. And at this point, this is where I said, well, let's see if we can write our own version of a replace algorithm that is both skipping certain elements and then also is only going to replace up to a certain number of characters, whether that's A or B. So let's take a look at that solution. So here I have my own hand-rolled replace and skip. And so what this does is it's going to skip to every third character or whatever value you specify for the skip parameter. And it's also only going to replace up to n of your value that you want replaced. So if you pass in 2, so like your begin and your end iterators here, F stands for forward iterator, and you pass in a 2 for n and a skip for 3, it'll do 2 replacements and skip by 3. And so you can see here pretty simply, we're just keeping track of how many replacements we've done with this variable c. Every time we do a replacement, which is this dereference of our iterator, setting the value equal to val, we do a pre-increment on c, and then we are performing our skip here, which is just a for loop, and we're doing a pre-increment on our iterator. And in each step here, we're making sure that we don't go past the last element specified by L here, and if we hit this, we break, and then on our first condition here, we will break and end this algorithm at that point. And then we can use this by the following. So here we've declared a local n, which is the length of our string, equal to a plus b. We do our fill construction of our string s the same way we were doing it before, and we calculate the pair and the value d the same ways we did before, and then we just make 2 calls to replace and skip. So for the first one, we are starting at the third element in our string, which is begin s plus 2, because begin s is the first element, begin s plus 1 is the second, and begin s plus 2 is the third. We go all the way to the end, and we want to do the maximum number of replacements as possible. And then we are going to skip by 3, and we want to replace the character by the one that we didn't initially construct our string s to include. And then we make a second call to replace and skip, where we start from the second element, not the third, and then we do maximum d, which is the leftover that we have to do from our first replace and skip, which could possibly be 0, which means we wouldn't end up doing anything. And then we're skipping by 3 once again and making a replacement to the same character we were in the previous call. So there's an improvement we can make here, and that's here we're doing this sort of inner for loop and then checking each time, does f equal to our past the last element. And we don't necessarily want to be doing this. So we can make use of the fact that our strings and the underlying data structure of string, basic string, supports random access iterators, which means that we don't just need to step by 1, we can step by skip. So if we move to our next solution, you can see that we've deleted the inner for loop, and instead of doing the skip number of pre-increments, we can just do a plus equals skip to f, and this looks a lot nicer. Everything else is the same below. But there's a further improvement that we can make, and that's that if we actually take a closer look at the 2 calls to replace and skip, we don't actually need the n portion of our algorithm for the first call, and that's because we know that if we're replacing every third element, we have to do all of the replacements. Like we're never going to end up basically hitting our n limit here, because the problem states that we have to be able to construct a valid string, and if we fill everything with a's and then are making every third replacement or every third character a b, we know we have to do that all the way to the end, otherwise we wouldn't have a valid string. So technically we could just call replace skip, and we could have a different version of this algorithm where we weren't keeping track of sort of how many replacements we did. But we'd still need replace and skip for the second call. But there's actually, if we change this to replace skip, there's a way to use replace skip to satisfy sort of the second call here, and that's just by modifying the end of our range that we're iterating to. So instead of passing in d as this value n and then breaking out of our while loop here, we can just modify the element that we are performing this algorithm on. So that brings us to, I believe, the last solution here. So we have our new algorithm, replace skip, so we don't need the n anymore. The code is the same, other than the fact that we have dropped the c, which was keeping the count of how many times we've performed our replacement. And we can see here that now we're making two calls to replace skip. So the first one is the same. We've just dropped the n, and we know that this is going to work. But for the second one, we need to slightly modify what we were passing in here. So before we were passing in the past the last element and then d, but we can just pass in the element that we know is going to be the last element that we want to perform this algorithm to, which is going to be basically the begin plus 1 element plus d times 3 of these replacements, because we're skipping by 3, and we know that we're going to want to do d of these replacements. So this will give us a range where we can perform d replacements, and then the algorithm will be over. And that's about it. There's only one thing I glazed over, in that this solution and just the previous solution, I changed the auto p to be using structured bindings. Note that this won't work with Leetcode because they don't support C++ 17, and structured bindings are a C++ 17 feature. But this enables us to sort of name our two values from our pair here, as opposed to using p dot first and p dot second. Note that lowercase c and capital C are not any better in terms of clarifying what they are, but it does just illustrate that we could give these better names and make use of a new or C++ feature. So the last thing to talk about is the time complexity, which for this is obviously going to be linear in big O of a plus b. And hopefully you guys found this interesting. I'm not sure if you guys would have preferred to just see another Python or Java solution as opposed to different versions of the C++ solution. But hopefully this is illustrative of how we can sort of make use of algorithms, even though the uses that I showed aren't the best, but then how we can also write our own versions of other algorithms. And if you look at this version or this algorithm, replace skip, and compare it to replace if, they're very similar. And if we start to think this way, and we can build up a library of our own custom algorithms, then in future solutions, you can just sort of refer to these and then write nicer code like this. Taking a look at the contests happening next week, there are 6 of them. 2 of them are from Code Forces. On Thursday, we have round 536, and on Saturday, we have an untitled round, but it is announced that it will be taking place that day. On Friday, we have 2 contests. From CodeChef, we have the February Long Challenge, and from Hacker Earth, we have the February Easy Contest. And we have 2 more contests on Saturday. From Top Coder, we have the SRM 749, and from Leetcode, we have the weekly Leetcode contest number 122. As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.